Hello students, in this tutorial I am discussing with you the case in which solid or axis of the solid makes an angle with HP, or you can say that your solid is inclined with horizontal plane. Okay, so let's see the question first. A cylinder with base 40 mm diameter and 70 mm long rests on a point of its base on HP such that the axis makes an angle 30 degree with HP. Draw the projection of the cylinder. Okay, so you can see here that this is my cylinder. It rests on HP on a one point. This is one of the point on the circumference of the cylinder. Okay, so this is rest on this HP on a particular point. Okay, so it's make an angle. You understand that axis makes an angle 30 degree with HP. So when the axis, you know that the axis is a central line and always passes through the center from your solid. So when axis passes from this one and meets with HP, it makes an angle 30 degree over there. Okay, so the diameter is given 40 mm and the length of the cylinder is also given, which is 70 mm long. So this is my imagination. And these type of questions, you know that you have to make some imagination, because from the front view you cannot see the true shape, and from the top view again you cannot see the true shape from the top view. So you have to take some imaginations over here. Okay, so first of all you have to make your imagination clear, then we will move forward. Okay, so let's see the imagination first. Okay, so this is my cylinder. You can see here, this is my cylinder properly. I'll show you some 3D part over here so you can understand better way. Okay, so you can see that this is your cylinder over here and rest on HP on one point over here such that the axis makes a parallel with over here with VP, and it likes this one. You can see it is very clearly. Imagination makes you very clearly these things. Okay, so this is like you understand proper way. So this is imagination. I think you understand the imagination now in better way. So it rests on HP over here, one point, and axis when passes through the center and meets the HP, it makes a 30 degree with HP. Okay, so this is your VP, it makes a front view over here, and this is your HP top view over here. And over here you can see that this is your front view. When you see this cylinder from the front side, this is your front view over here. Okay, and when you see the top view, so this is your top view. Okay, so this is a front view, this part is a front view on the VP, and this is a top view on HP. So this is our imagination in proper way. You have to take the assumption, okay, because from the front view you will see this rectangle only. Okay, and from the top view you will see on this circle, but it's not a circle, basically it's an ellipse. You can see that this is not a circle, this is an ellipse. It's elliptical form. So you have to take assumption over here. So what is the assumption? So you can see here. So this is my assumption. This is assumption case. Okay, so what I did now, I make my axis line, which is the axis line makes an angle 30 degree with HP. I makes my axis exactly perpendicular to HP over here. You can see that when axis line, when the center line passes through over here and meet with the HP, it makes a 90 degree instead of 30 degree now. In this case it is 30, but in this case it is 90. So this is my assumption to start my question. Okay, you can also see here. I'll show you. I'll rotate it. Now you can see that. Now see this. I'll rotate this now to make my cylinder exactly perpendicular to your HP. So this is my assumption. You can see that if I'll make like this, it exactly now the axis is now again perpendicular to your HP. Okay, now this is the starting point now. So now you can see that from the top view you will see this complete circle now. Instead of ellipse in the previous, when it is inclined with HP at the angle of 30 degree, then you will see the ellipse. Okay, but in this case now you will see the exact circle, and in the front view you will see exactly rectangle over here. Okay, so this is the starting point of my question now. So you can see that. Now how to start it? You can say this is my imagination. Now I'm going to start it. Now first of all make axis XY line. So this is my XY line. Okay, up to this one. Now you know that in the top view you will see this circle. Okay, now take a circle command. Now I'm going to make the circle over here. So these are circles. This is 20 mm radius. Now I'm going to divide this circle into 8 or 12 equal parts. I'm going to divide it into 8 equal parts. So how to divide it into 8 equal parts? I'll take a line. Okay, go to the center point of the circle and make a line over here exactly orthogonal. Remember it, exactly orthogonal over here. Okay, now instead of making the division of this circle with the help of angles, I'm going to use the array command over here. Okay, and array command, I'm going to use the polar array. Okay, so polar array, I'm going to select this line now because I want to array this line, and select the center. So you can see that it automatically or by default divide this circle into 6 equal parts, but I want to divide this circle into 8 equal parts. So I have to select over there and select the items, and when I write down the 8 and enter, it divides into 8 equal parts. Now you can see that this is 8 equal divisions of the circle. Okay, so now I'm going to give the nomenclature over here. So take the text command and going to give like this. This is okay, and make them copy and put over here 1 2 3 basically 4 5 6 7 and 8. Okay, so you know that this is basically 2, so I'll select this one, and this is 2. Okay, so this is the nomenclature of the one of the face of the cylinder. You know that cylinder have two faces, so this is the visible face to me from the top view. So I'll make this one is 1 2 3 4 5 6 7 8. Okay, so opposite faces I'm going to make it alphabetically, so that is A B C D E F G H. Okay, so I'll make like this again. Okay, so this is the nomenclature. Now I'll delete this one, I don't need this. So this is, you can understand in this way, this is 1 2 3 4 5 6 7 8. This is this one face because this is a visible face from the top view, and this is ABCD face is this one because this is not visible to you, but this is a face opposite to my visible face. So you have to give the nomenclature in this way in this projection of the solids. So this is 1 2 3 4 5. This is ABCDEFGH. Okay, so I'll take the projections towards the reference line for making your front view over here. Okay, so you know that you have to take the projections from every and each point. So this is one, now this one, again take a line, so this one, again this one, and this one. Okay, so this is the way to take the projections from each and every corner. Okay, so I'm going to make the front view over here, and you know that from the front view you will see this on rectangle. You can know that, so you can easily see here in this imagination. So this is the top view, you can see this is a circle, and from the front view you will see this rectangle only, and the height of the solid is given, which is 70 mm over here. Okay, so make the 70 mm. Now take a line, this is 70 mm. Okay, now I'm using snap like this, and this one and this one. Okay, so this is a rectangle over here, you can understand this way. Okay, so this is your front view. Now take the projections towards upside to complete your. Okay, so this is the way to give your front view of the cylinder and on the vertical plane. Now I'm giving the nomenclature over here, and you know that this face is 1 2 3 4 5 because this is a visible face. You can see here this is 1 2 3 4 5. Okay, and this downward face is A B C D E. Okay, so you have to give the nomenclature as well here. So I'll use again copy command to complete my nomenclature over here. So this is 1, and I know that this is 1 dash, so I have to make like this dash, as this is a front view. You know that, and you know that when you see this point 2 and 8, you will see this 8 point first from the front view. Okay, and 2 point afterwards, so you have to write over here 8 dash 2 dash. Okay, so again I'm using copy, this one put over here, and this is 8 dash and 2 dash. Okay, so this is done. Now in the same way all the nomenclature is done in this way. Okay, so this is the nomenclature of my front view. I hope you understand this thing. And now I'm going to make the actual view. So you can see that this is only assumption to start my question. Okay, so this is only assumption. Now this is the actual position. This is the actual position of my cylinder as per the cosine. You have to rotate your cylinder or axis of the cylinder exactly at an angle of 30 degree with HP. Okay, so you know that the axis line is here, so you know that this is your center, and when this axis line passes through the center in the front view, it will be this line which is axis line, because in the backward of this line you can see that this is actual which line, this is this line, this one. Okay, and from the front view you will see, you cannot see the axis line because it will overlaps with this edge or this imaginary line of the cylinder. Okay, so you have to assume that when your axis is at an angle of 30 degree, it means this line is exactly at a 30 degree with HP. Okay, so you can see in imagination as well. So this one, now I'm going to rotate this one now. This is rotation from assumption to actual condition. So you can see that this is actual rotation now. Now when I rotate it exactly at a 30 degree, this is axis line passes through over here and makes an angle 30 degree with HP. Okay, so it will gives you in this way. So this is your again front view and this is your top view over here. Okay, so this is a better way to understand this question. So I'll going to make now I'm rotating this one. So I'm going to rotate in this way. I'll select this one as well, and this one, and I'll copy it and put over here. Put your ortho is on and put over here now at some distance. Okay, now I'm going to rotate exactly this one over here. Okay, so you will see that when you are rotating this way, when you're this line makes an angle like this 30 degree with HP. So how to rotate this one? I'll take the rotate command. I'll select this one and this one as well, enter, and select the base point. This is my base point. Now you will see that after selecting your base point it starts rotating. Okay, so now my angle is basically not 30 degree. Okay, why it is not 30 degree I'll tell you after making it, but my angle is 60 over here. Okay, now you'll show that 60 and enter. Why it is like 60 over here I'll tell you, because you know that I'll assume this line as an axis line. I'll extend this line towards there. So take extend now, you can see in better way now. So you can see that I'll take that angle now, dimension and angular, and this one and this one. You will see that this is 30, but in that I'm going to take 60. Why? Because I'll take this line, basically I'll take this line rotation at an angle of 60, and you know that this angle is 90, this angle is 90, and this is 60, this is 60, so it automatically is 30 as per rule of mathematics. You know that in the triangle the sum of all the angles is must be 180. So if it is 90 and this is 60, it automatically is 30. Okay, so that's why I'll take the 60 instead of 30, because I'll rotating this line basically over here. Okay, by the rotation command you will rotate like this way. So I'm going to rotate this way of the complete solid, not this particular line. So that's why you have to make like this front view, actual front view. Now I'm going to make a top view with the help of this one. So take a projections downwards, and this one and this one. Okay, so you know that this is actually a 1 2 3 4 5 face, and this is A B C D E F G H. Okay, so I'll take this one as well. So and this. So this is my projection lines from the front view towards your top view. Now I'm going to take a projections again. You know that you have to take the projections as well from here. Okay, so this is the projection from every points from your this top view to make this actual top view. Now you know that first I'll give the nomenclature over here so you can understand which face you are going to join in proper way. So you can understand which face is which one, and I'll take nomenclature in this way. You know that this is a copy and this one, and I know that this is actually a 1 dash, and again I'll going to take this one, copy and put over here, this one, copy, put over here, copy and put over here, and this one, and copy and put over here. Okay, and I know that this should be 51 dash, remember it, this is 51 dash, and 1 should be in the subscript. Okay, so in the same way all should be like this. Okay, so this is, you know that this is 11 dash, 81 dash, 21 dash, this is all should be like this. In the same way you have to write this one A1 dash, B1 dash, like this. So okay, so I'll again use copy, and you know that this is a point, and I'll make like this is a, the same way these are also. So select this one, this is A1 dash. Okay, so this is the way to give the nomenclature in the front view. Okay, now I'm going to take it in the top view now. So you know that this is the points, these are the grids of the intersection of your points. You know that this is one, and one is coming from this projection line, and from the front view one is coming from this one. Okay, so wherever these two projection lines meet, that should definitely be 1. Okay, so this point should be 1 over here. Okay, so I'll give the 1 over here, I'll copy and put your 1 over here. So this is 1. Okay, so this is again 1 1, you know that this is 1 1, and okay, so this is 1 1. In the same way, students, so this is the nomenclature of the top view. I'll locate all the points, and I'm going to make my actual thing, you know that. So you can see here from the top view you will see this ellipse, and this ellipse you will see only this one, the other part is hidden. Although there is a ellipse also here, you can see in this way, I'll show you. So you can see that this is the ellipse, the complete ellipse, but here you have ellipse, and only this form is visible to you from the top view, but that this view is not visible to you. You will see like this way. Okay, so you can see that both are ellipse because we have two faces over here. Okay, but this face is visible only in this side. This face is not visible to you, this one is. Okay, so you can see that in this way hidden. When I'll see the hidden, only the hidden part is not shown to you. Okay, so this is the actual exactly top view, which will be I'm going to make. And now you are going to take an ellipse now. So take an ellipse, and you know that this is, and this one, and extremities of this one is like this. Okay, so this is very much visible to you, this face, so make it thick so you will understand proper. Now I'm going to see this one. I'll take an ellipse again. Okay, take the ellipse, this one, then this one, and extremities of this one is here. Okay, now again you know that this part is visible. You know that this part, half of your ellipse is visible to you, but this ellipse is not visible to you. Okay, so you have to take a trim now, and I'll select this one, and I'll make like this. Okay, so this is visible to you. Okay, make this thick. Okay, now I'm going to make the lines over here. So this one, and again take a line, and this one. Okay, make these lines thick like this. Okay, so now I'm going to make the hidden part. So hidden part is important over here again. So again I'll take the ellipse, again the same thing over here, I'll take like this way. Okay, now I'm going to make this hide. So this is the way you can see this. Now you can see that this is a hidden part. Okay, so this is the completion of my question. Okay, now I'm going to make all other things thick. You know that this is thick. You have to make the extremities of your cylinders thick like this. Okay, in the same way, this one, this one, this one, and this one is as well thick, and this one is also thick. So this is the question, you understand. So very important, the imagination is very important. Now take the dimensions now. So first of all, take the angular dimension, which is very important constraint in this. So you know that this is 30. So you have to show 30 over here. So 30. Okay. And the length, which is 70 mm, it should be, and this one is 70 mm. Now the diameter, so this is 40 mm. Okay, so this is the way to give your dimensions and nomenclature of this question. I really hope you understand this question. The imagination helps to understand this question very easy. So I hope you understand this question. If you still have any query about regarding this question, please comment in the comment section. Okay, I'll tell you the answer regarding that. Okay, thank you everyone.